primary areas of interest in the early part of the application of mass spectrometry was in the discovery of the isotopes, the elements. And there were a couple of major actors in that in the period of about 1918 to 1940. The two that I'd like to talk about are Arthur J. Dempster, a Canadian-American, and Francis W. Aston, an Englishman, both of whom did fundamental work in the discovery of the isotopes for various elements. I'd like to talk a little bit about Dempster first. He was a Canadian citizen, born in 1887, was educated at the University of Toronto, taking both bachelor's and master's degrees there, and then decided to go abroad to study for a PhD under Wilhelm Wien, who was then at the University of Würzburg in Germany. He had 2 years into his doctoral studies when hostilities looked imminent between Germany and other nation states in Europe, and he wisely decided that it was opportune to leave Germany and return to the United States or to America because of the possibility that he could have been interned during the subsequent war, which did happen to one of his friends. He went to the University of Chicago and continued his doctoral studies, completing them in 1916. And interestingly, he decided to become an American citizen during that period, and also to enter the United States Army, where he served for several years before leaving the Army and then joining the faculty at the University of Chicago. His original research was to follow up on J.J. Thomson's positive ray analyzer, and he actually built one in his lab at the University of Chicago and used it to investigate what he called slow canal rays, which we would call positive ions that are created at relatively low energies. As you may be aware, should be aware, that the fashionable method of creating ions at this particular point in time was in a gas discharge ion source, which meant that you had a very energetic group of ions, and that required two fields, both electric and magnetic, to form a separation that was useful. But by using slow canal rays, as he called them, he didn't really need the electric field, and was able to create an instrument, the 180-degree magnetic sector Dempster mass analyzer, that permitted him to obtain mass spectra of these compounds and elements without having to have an electric sector. This slow canal ray ionization process really basically was like the precursor to what the modern electron ionization or electron impact ion source. He and Aston competed for discovering the various isotopes of the elements, and up until about 1923, when Aston received the Nobel Prize in 1922, and then Aston continued in investigating the isotopes, but Dempster kind of abandoned that and directed his research in a different direction, different area. About 1935, he decided that there was some utility in the spark source to ionize metals. One of the problems with the gas discharge ion source, of course, is you had to compound the element of interest into something that would be a vapor at room temperature. By using the spark source, he could actually create ions directly from metals. And he did this for a series of metals in 1935: uranium, iridium, palladium, gold, platinum, rhodium, and thorium. So this was a very important step forward, and he was he was able to determine the first person to observe uranium-235, the fissionable isotope of uranium. So Francis W. Aston was Dempster's contemporary, who also investigated the isotopes at the Cavendish lab in England. He was born in Birmingham in 1877 and studied both physics and chemistry at the University of Birmingham. It's important that we note that he did study chemistry, because he later received the Nobel Prize for his work, and it was a Nobel Prize in chemistry, not physics. He actually worked as a chemist in a brewery for 3 years before he returned to the University of Birmingham and to begin graduate work, further graduate work. During that period, he discovered what was known then as the Aston dark space when he was studying gas discharge phenomenon. He became a lecturer at the University of Birmingham in 1908, but J.J. Thomson enlisted him to come to the Cavendish lab in 1909 and to work with him on work that Thomson was pursuing in positive ray analysis. World War I interrupted this period, and Thomson actually worked for the Royal Aircraft Establishment in Farnborough, England, during the war period. After the war, he returned to Thomson's lab and started using the positive ray analyzer, and he too, just as Dempster had realized, he had to come up with a different analytical tool if he was going to do serious work in measuring the isotopes of the elements and the various properties of the elements. He was an extremely good experimentalist, and he very shortly came up with what became known as Aston's first mass spectrograph. And with it, he confirmed the presence of the neon-22 isotope, which had been a subject of some debate from the time that Thomson had discovered it about a decade earlier. In 1922, he was awarded the Nobel Prize in Chemistry for, and specifically, it's always good to know exactly what this prize is awarded for his discovery, by means of his mass spectrograph, of isotopes in a large number of non-radioactive elements, and for his enunciation of the whole number rule. And I think it's important that this prize citation indicates that it was for the non-radioactive elements, because this was a topic of some discussion in the 1920s as to whether or not stable elements, such as carbon and oxygen, could actually have isotopes, stable isotopes. Thomson and the Cavendish lab eventually became the ultimate authority on the isotopes, and published in 1922 a book called Isotopes. The developments in that field occurred so rapidly that by 1924 he published a second edition of that book, and he followed it up in 1933 with what really would have been a third edition, but which he called Mass Spectra and Isotopes. And by 1933, a significant number of isotopes of the elements had been discovered. And basically that is Aston's primary contribution to science, is all of the work that he did on the isotopes of the elements.